You're busy looking at their hair, their shoes.
No, I'm looking at the wall. Things on the wall.
I am sitting here talking about Jesus Christ, and you're looking at my shoes. All right, here we go.
But you never wear boots. You never wear boots.
Okay, that's because my toes look really bad after this weekend. I have to do them. I didn't want anyone to see them. Okay, simplifying
I can relate.
algebraic expressions. Whoops. Simplifying algebraic expressions. Blah, 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 blah. Okay, we have several pages. No, not really. We have 2 pages. But it's not yucky stuff. It's yucky in the fact that we are dealing with fractions and decimals, but it's the concept behind it that is really important to know for algebra itself. And again, remember Algebra 1, which is what you should be taking next year if you do well in this class. It's the same stuff as this, it's just taken up a notch. Okay? Intruder alert, finding out what the variable means, isolating variable. And what we're doing today, 2 huge things in algebra. I mean, like almost the basis of algebra. Okay. And we're still recording. Hold on. Technical difficulties. Okay.
Yeah.
Okay, here we go.
Cheers.
I haven't talked this much already in a week. Okay. Decimals and fractions. Even if you hate them, which I did growing up, hate them. I would rather not even teach them because I hate them so much. But even though I hate them, and some kids hate them, Algebra 1, there's a lot of it. So we've got to get used to it. Let's get started. When you're simplifying algebraic expressions, you're basically making them, I refer to it as smaller, easier to deal with, okay? You're combining things. In fact, you're going to combine like terms. You're combining like terms, and this is very important when it comes to algebra because simplifying is part of the basis of everything. You've got to know what things you can put together and what things cannot be put together. I'm going to put 2 stars here. You can't add or subtract different variables. And what are variables again? Letters. Can't add or subtract different letters.
Weren't we never able to do that?
Like you can't add 2A plus 3B. It's not going to give you 5AB. But you'd be surprised how many kids want to do that. So you cannot add or subtract different letters.
Oh, yeah.
However, you can multiply or divide different variables or letters. You can multiply or divide different ones. That is what we're doing today. And that's the hard thing. A lot of kids forget that you can't add and subtract different letters, but you can multiply and divide different letters. And one little thing before we get started, when multiplying variables, I want to say we've done this before. You can use the cancel method.
Yeah, we have.
Cancellation.
Yep. But I think we've messed with the letters before.
Wasn't it that one time you told like you were doing it? I said, can we reduce them or something like that? You said, can we work it out separately and get the same answer?
Oh, girl, I don't remember. You're asking a lot. I had trouble remembering how to set my alarms for today's classes. I didn't even look at schoolwork until about 11 last night.
Really?
No, I took a break from school.
I was sleeping.
All right,
You shouldn't even be in school. You're an adult.
She wasn't in school.
examples.
She was trying to teach it again.
Yep, we're going to jump into examples. So open up your book, page 242.
242, why? There's notes on 241 and 240. That's all the notes.
Because I'm so confident you guys are going to get this, we're jumping right into examples.
That's very brave of you.
Mhm.
I don't like
I know, the Monday after Thanksgiving, I
Do you
jump
have
right
any
in.
germs or under your nails and your cuticles and stuff?
I needed, oh my gosh, I thought about y'all this week.
Thank you.
No, I mean like with the germs thing.
You made me a germaphobe, so.
I should have taken that stuff with us on the trip. There's so many times that it was so bad, and I'm not going to discuss it.
Your phone has more germs than a public restroom.
Mm-hmm.
No, Kelly, keep writing. We're waiting on you.
Just.
Then love knowing that fact. I hate knowing it too.
Okay, so is everyone on page 242?
Yes, ma'am.
Okay, let's look at number 2. Now, this class is really good about this. Sometimes not so much, but guys, y'all refreshed to some degree.
My stomach.
If you will follow my tips, you will do fine on this, okay? So look, 2a plus 4 over 5a minus 3a. Okay, we're only adding and subtracting here. There's no multiplication or division being done, right? Okay, Atalia, how many terms are there here?
3.
That's right. See, I knew we've done this before. 1, 2, 3 terms. Does everyone see that? 1, 2, 3 terms. Y'all see that? Okay, so if simplifying algebraic expressions means combining like terms, do you see an equal sign here? So we're not doing intruder alert. We're not solving for A. All you're doing is simplifying this expression. This is an algebraic expression. Simplifying meaning you're just combining the like terms. You're making it, what I say, smaller, easier to deal with. So, Atalia, we have a 2a, 4a, and a 3a. Are these like terms?
Yes.
They are. There's no b, there's no c. This isn't a squared. If it's a squared, we couldn't combine it. See, remember, we've done this before. So then, which terms can we add and subtract together?
2, 4, and 3.
So all of these.
What about the 5?
Well, that's what she means, 4 over 5. So here's what I tell my students to do, and I think I've even done this with y'all.
Yes.
You circle the like terms, including the sign right before them. Meaning I can combine all 3 of these. Now, Atalia, to combine these, one thing we've got to do is, this is a fraction. So what do I have to do to these two? Okay, we got to turn them all into fractions. So how do you said put a 1 underneath it, right?
So 2a over 1.
Look what I'm doing, boys and girls.
times 4.
And then stop me if you have a question or if you don't understand what we're doing. Kelly.
This is what I'm thinking right now. You turned it into fractions because of the 4 over 5, right?
Yes, ma'am.
So right now, are you going to multiply it?
No, we're adding and subtracting.
Since we're adding and subtracting fractions. So, Atalia, what is the thing that we've got to do? They all have to have a common or like denominator. So before I move on, does anyone have any questions as to why we did what we did here? Tanner, do you understand? Because of this bad boy right here. If it was just 4a, man, 2 plus 4 minus 3, we'd be done, right? But because this is a fraction, now we've got a headache. We've got to turn these into fractions, which means we put a 1 underneath it. And then we've got 3 fractions, and we can start adding and subtracting. However, we do need a common denominator. What would be that common denominator?
5.
This fraction doesn't change because it's a 5.
And then you would do, okay, because 1 goes into 5 times, you multiply 2 by 5.
That's right.
As the 3.
So do you see that, Tanner? 1 goes into 5 times, so 5 times that numerator gives us 10. Joseph, do you see that?
Yes.
Okay, so this fraction didn't have to change because we're using that same denominator. But we had to get common denominators here. And if we change the denominator, we have to change the numerator. 1 goes into 5 times, so we do 5 times 2 is 10. Make sure when you're copying your notes, you're even putting my little times 5 there so that when it's time for you to do your work, if you're like, how did they get that 10? You can look right here. Okay, Atalia, 1 goes into 5.
5 times. So you multiply 3 by 5, which is 15.
Whoops, oh, sorry, 15. Does everyone understand where we got these 2 fractions? Okay, so now they are common, they're like terms because the a's are the same. So then 10a plus 4a is what?
14a over 5.
So I'm going to go ahead and say 14 over 5 minus 15 over 5a.
And then
Do you see what I'm doing? And then, Atalia, what do you get?
you get negative 1 over 5a.
I want everyone to write that down and then tell me if you understand or have questions. Tanner.
Where'd you get the negative sign?
Okay, right here. 14a minus 15a because 15 is bigger.
Oh.
Are you saying that just because, or do you really
No,
understand?
I understand.
Okay.
I thought the 14 was a 15 and the 15 was a 14 for a second.
No, I understand. And it's been a while since we've done positives and negatives. So I understand. That's a very good question. Kelly, you had your hand up too.
So just to clarify for me, because I want to make sure I know this, you added the 10 and the 4, correct?
Yes, we added, so we have 3 terms, and I should have probably written it underneath. So 10a, 5 over
10 over 5.
10 over 5a plus 14 over 5.
4.
4 over 5.
See, I'm suffering too. That gives me 14 over 5a minus 15. See that? These two give me this. Do you see that, Kelly? I should have written it like this. It was probably better. And then I brought down this.
And then, okay. Yeah, I see it. But I was just making sure to clarify for me.
Yeah, because I should have written it underneath. Because this would have probably made more sense.
Because I don't know. I have a question.
Yeah.
Can we redo this problem with different numbers and letters?
Well, I'm about to do another problem.
Oh.
Would that be helpful? I'm not going to do everything, but we're going to do more. we're gonna do more, don't worry. Any other questions?
Y'all are confusing me.
Does anyone have any more questions on 2?
No.
Okay, so basically what I'm seeing is, and when I teach, I call it fishing. And, yep, fishing.
Hook us and really.
And that's right. If you've ever been fishing, and some of you may not, if you go fishing, sometimes, you throw your line out and you may get a little nibble and you see your little bobber or something go down or something like that. Okay, well, So anyway, you've got the fish are nibbling. Sometimes you'll hook one, you're reeling it in, and they fall off before you even get to the side, okay? Then there are times when you're fishing and you get all the way to the shore, take it out. Teaching is the same method. I look at my students. Some of my students are just nibbling. They're like, yeah, I understand that, but I haven't caught them yet. Some of my students will grab hold, but then let go before they're to the shore. And then I don't stop teaching until all my students are on the shore, in my cooler, and later in my frying pan. Because seriously, if I'm fishing and I leave some of my students to just nibbling on the bait or not completely hooked and they fall off the hook, the bait, they're not totally hooked. That's math. That's teaching math.
But then that sucks though. Whenever you're already hooked, but then.
No, it doesn't, because all you're doing is it's sealing it in. You're just sealing it in. And what you're doing is you're on the shore coaxing the others. Take that bait, man. Take that bait.
Why
Come
do I want
over
them to die
here.
with
You're
me?
gonna die on your
I
Okay.
don't want them to die with me. I
No,
want them to stay
you're not.
alive.
Wait,
Here, no.
Hold on. Is the fishing pan the test?
What?
Okay.
Frying pan.
Is the frying pan where you cook them the test? Starting
Sure.
Well, no, your last breath is the test. And if
All
you
right.
fail, you die.
Let's look at number 4.
Wow.
Negative 8W plus 1 over 4W minus 3 over 4W. Okay, so, Tanner, how many terms do I have here?
3.
That's right. Are they all like terms?
Yes.
That's right. So I can combine all of these, right? So I'm circling them all. Now, I have 2 fractions here. What do I need to do to this bad boy?
Put a 1 under it.
That's right. So I'm rewriting my problem. So it's going to be negative 8 over 1W plus 1 over 4W minus 3 over 4W. All right, Kelly.
Yes.
Now I've got all 3 of my fractions. What's the rule when you're adding and subtracting fractions?
Make sure they all have the common thing on the bottom.
Common thing on the bottom. The bottom number, the denominator has to be the same. So Kelly, I have a 1, a 4, and a 4. What would be a common denominator?
A 4.
Okay, so I'm doing more arrows. These fractions right here don't have to change because they've already got the common denominator, right? So I'm going to have plus 1 over 4W minus 3 over 4W. All right, so here, Kelly, I'm changing that to a 4, but if I change the denominator, I have to change the numerator, right? Right, Kelly?
I can't even. Hold on. So then you have to multiply 4 times 8.
Okay, so 1, shh.
1 times 4.
1 goes into 4 times, so 8 times 4 is?
32.
All right, so now I'm going to do my adding and subtracting. All my fractions are ready. Let's go with these 2 first. Negative 32 over 4W plus 1 over 4W. Tanner, what would that be?
Negative 31 over 4W.
Yeah, man, negative 31 over 4W. And then I bring this one over, minus 3 over 4W. Good job.
Like that 4.
Okay, Joseph, Negative 31W minus 3W.
So it would be negative 34. 34W.
Is that in lowest terms?
No.
What can we divide the top and bottom by?
4.
4 can't go into 34. How about 2?
Oh, yes.
So 34, negative 34 divided by 2 is? Joseph?
17.
Over
17 over 2.
W. Does that help, Taylor?
Thank you.
You're welcome. Yes.
So, okay, for, this is just general, but for the W, is that representing the whole fraction or just 34?
Okay, so that's kind of like the negative sign. And this is a very common question. The negative represents the entire fraction, just like the W. But if you were to separate them, they would go with, it's the whole fraction. It's basically saying this, if you really want to look at it, this is saying negative 17 over 2 times W. That's what that is. So the W is with the whole fraction. Okay. Any other questions before I move on? All right, good job. Tammy, you got one? Okay. Look at number 10. Hold on. All right, I got 10. Kelly, you want to do this one?
Yes.
9 over 11A plus 2 over 5A minus 1A.
Okay, so you turn.
Which are like terms?
Which are like terms?
Yeah, which, all of them, that's right. All of them are like terms. Because they each have this A. Now what am I going to do?
Now you're gonna change the bottom number for all of them.
Well, this is a whole number.
So it has to be 1 over 1.
Okay, so we changed that one. I'm bringing all of them down. And yes, it's extra writing, but it's good to write it step by step. So because of these two fractions, I have to change this whole number to a fraction, and I just stick a 1 underneath it. Good job. Now we have 3 fractions that we're adding and subtracting. I need to have a common denominator.
55.
Okay, so 55 would be the common denominator. All right. So Kelly, how many times is 11 going to 55?
5 times.
So 9 times 5 is?
45.
Good. 5 goes into 55.
11 times, so it's 22.
11 times 2 is 22. And 1 goes into 55. 55 times.
Oh.
Right?
Yeah. And
So 55 times 1 is?
55. Yeah. Definitely.
Okay. So Kelly, go ahead and tell me. 45 plus 22
67.
over 55A minus 55 over 55A. Because I'm rewriting my third one. And this time, because this is a positive and that's a negative, we subtract and keep the sign of the larger. So what do you get?
You get. My mind's going blank. 12.
over
55.
and A. And that is in lowest terms. Any questions? Yes, ma'am.
How many of these are we gonna do?
We have 3 more. Any questions? All right,
Can I do the next one?
sure. 12. Now we're doing decimals. 428.9 Z minus 3.69 Z, which I think are a little bit easier than fractions.
Yeah, like
62, you don't have to get common denominators. And then plus 62.5. Notice there's no Z. So Tanner, what are your like terms? What are things that we can combine?
The 428.9 and 3.69.
That's right. These are the only ones we can combine. Perfect. We can't combine this with them because there's no Z. So we're going to combine those. And over here, I'm going to write 428.9. Now, with decimals, when you're adding and subtracting, what's the rule, Tanner?
You have to move the decimal.
You have to line up the decimal. So since I have 3 points, so I'm going to do 3.69. See how I have it set up? You line up the decimals. I'm subtracting. What can I put here since I'm subtracting?
0.
That's right. And if you want, you can even put in zeros there, anywhere you have a space. So make sure you line up those decimals. So Tanner, 0 minus 9, we got a bar, right?
So that would equal 1.
So that's 10 now, correct? So 10 minus 9 is
1
8 minus 6.
is 2.
Now, when you're adding and subtracting, you just bring down your decimal. You don't have to count or anything. 8 minus 3 is
5.
2 minus 0.
2.
And 4 minus 0.
4.
So this is 425.21 Z. And then we just bring this guy over. Plus 62.5. And guess what? You're done. You can't combine those two because there's no Z, so you are done. You have simplified that expression. Get it? Any questions? All right, let's do another. Natalia, you want to do this one? All right. Negative 2 over 9 times y minus 3 over 5 plus 5 over 9y. All right.
Oh,
Yeah, you're it.
okay. So we have to combine like fractions. Or like, yeah.
What's going on here?
Well, distributive properties.
Bingo. Remember, if you can't combine what's in here, you can't combine the y with this fraction because they are not like terms. Here we have a parentheses with something right on the outside that's multiplying. So we do distributive property. We're multiplying the negative 2 over 9 times the y and the negative 3 over 5. All right. Natalia, what is negative 2 over 9 times y?
Positive.
Nope.
Well, it's saying subtract.
Negative
Oh, times y. Sorry.
times positive
Oh,
y.
Okay. Negative 2 over 9y. I was looking at the other one.
Now, negative times a negative is positive. Do y'all see that? Negative times a negative is positive, so plus
6 over 45.
okay,
How'd you get that?
2 times 3, 6, 9 times 5, 45. You got it? Plus
Plus 5.
5 over 9y. Okay, so Italia, what are my like terms?
-2 and -2 over 9y and positive 5 over 9y.
Do y'all see that? This guy doesn't have a y, so we're not going to be combining it.
Makes it a little easier to have like the home.
Makes it a whole lot easier. So we're going to combine these.
Which is, can I say?
And since they both have a common denominator,
That's nice.
is very nice. She didn't have to make any changes. So what we have is -2 over 9y plus 5 over 9y. So what do you get?
Positive 3 over 9y, which,
Hold on.
and then plus 6 over 45.
Now, we're rewriting that guy because it's not being combined. Does everyone see this? Yes, ma'am.
Wouldn't the 3 over 9y be negative?
No, because this is a negative, the 2 and the 5 is positive, it's the larger number.
Okay.
So you subtract and take the larger. Does that make sense?
Or I think they don't even know.
Now, we look at our fractions. Can we reduce either one? What does this reduce to?
1/3 of
1 over 3,
y.
y, because it can be divided by 3. And how about this? This can also be divided by 3.
About 3, yeah.
So what do you get?
2 over 15.
And that's your answer.
Forgot about 3.
Any questions? So first we did distributed property. Set it up. These are our like terms. We added them, or actually subtracted them. And then we bring down this loaner. And then we make sure our fractions are in lowest terms. Any questions? One more. Joseph, you want to do this one? 18. And then I'll set you free.
Oh, the O.
Negative 6.8w minus y plus 0.69w plus 8.24y minus 2.9.
So you can combine -6.8w and 0.69w.
And notice I'm circling the sign in front. Now what can I combine?
-y.
And look, I'm doing a square.
And 8.24y.
Can this negative 2.9 be combined with anything?
No.
I'm going to put a flower around it because I don't want to accidentally forget it.
Or cloud.
Or cloud, yes. All right, so
Write that one in the middle. I was like, where did he get
I'm going to put these in parentheses. Negative 6.8w, cross it out, plus 0.69w, cross it out, and what do, bless you, what do I put in between the parentheses?
A plus sign.
See, y'all have done these before. Negative y, cross it out, plus 8.24y, cross it out, and then minus 2.9, cross it out. So I'm combining all my groups. All right, Joseph.
So first you want to combine -6.8w and 0.69w.
And I line up my
Decimal.
decimal. And since they are different we subtract. So what do you end up getting? What's your final answer?
6.11. Negative 6.
Negative 6.11 W. If you subtract correctly. Yes, ma'am?
Isn't adding negative 2.9 and subtracting negative 2.9 the same thing?
2.9?
Okay, so if I were to say plus negative 2.9
Oh, yeah.
and then minus, is that
As
the
long as
same
you
thing?
put that in parentheses.
Yeah, it's the same thing.
Yeah.
Okay.
Okay, so right here, we're going to also subtract. I have 8.24y. If I don't have a number here, what do I pretend is there?
0. A 1.
A 1. If we don't have a number, we have a 1. So that would be a whole 1. And it would look like that.
What if I just put the 1 and 4 without the decimal?
Because there would be a 1.
Do I have to?
If you put the 1 over here, you're going to get a totally different answer.
Well, if you just like make sure like.
If you put
You
the
still put the
1,
decimal in the right place though.
if you put a 1 under that 4, you will get a wrong answer.
Well, not always.
4 minus 1 is 3.
Which goes 8.2.
Where this is 4
Yeah.
minus 0.
Yeah, I was thinking something else.
So if we don't have a number, we pretend there's a 1, and because there's decimal, it's a whole 1. We have to line up our decimal. So make sure you're writing this in your notes. What do you get?
7.24. Y.
And then we just bring this guy down. Because he can't be combined with anything. And then we're done. Any questions? No?
Are there gonna be any other questions like this?
Well, I'm sure. Alright, so you're doing page 242 to 243. And you're going to do numbers. That was, what number was that? 18?
Yes, ma'am.
1, 2, How about 9 problems? 1 through 17 odd.
You're blessing.
Yeah. That's 9 problems due Tuesday. Your test is Thursday.
Thursday, due on Tuesday.
All right? Get to work.
Done.
Pause.
Okay.
Oh,
Is it
Oh,